Okay, so hello everyone. Let me also, as usual, we still have 2-3 minutes. So until people are able to join, if you got questions, please feel free to drop these in the chat, and then I will make sure I will try to answer them before we start.
Sir, I have a question.
Yeah, go ahead.
I'm just a little bit confused on deallocation. So in the lab, the last two questions you ask to deallocate the memory in question 2, right? So once you deallocate, is the array, like whatever you deallocate, like let's say, so for the withdraw function, right? You say to pick like a student number and then it deallocates that one. So what you're asked to do is to shift every single element up one, right? So then what happens is the one that you're looking to withdraw ends up at the bottom. So once you free that, is the array supposed to still hold the values, or is it supposed to hold garbage values?
You mean the remaining of the array or the array entry of the student that you removed?
The array entry of the student that you removed.
I see. Yeah. So this is going to, if you deallocate it, then it's not even, it's no longer part of the array, right?
Okay.
Because it just gets removed. It's not part of the memory allocated to you, right? So you
Right.
have already deallocated that, yeah. So by doing this, you make sure every time you add a student or withdraw a student, you only have in the memory what is really needed for you to be able to, like the number of students. If you have 10 students, you only have 10 locations for you are reserved in memory. If you take one out of these, then you only maintain 9, right? This is just to make the memory usage efficient, right?
So then how come that array element, like that index, still holds the value of?
How come this array index? So the thing is, okay, good. So what does free do, right? So I guess that's the fundamental question here. So free is simply making this memory not reserved to you anymore, which means any other application can try to reserve this memory when needed and use it. Previously, when you allocated this, no other application is able to access this part of the memory, right? So I guess your question is, maybe after allocating it directly, if I check the value, it might still be there, right? Yes, but that's a dynamic thing. Maybe no other program used it yet, right? So it's not overwritten, right?
Okay.
Do you see the point?
So
But
it's
it's more
able,
about the authority. Sorry, go ahead. Go ahead.
so it's able to be overwritten now because it's been deallocated. But since I'm checking right after I deallocated, that's why it's still there.
Exactly. Yeah.
Okay. And in terms of when I push it, so that I'm getting the check marks on Git, so which means that it's probably correct.
Yeah, that's correct. I mean, make sure you add also your test cases for that, right?
Okay.
Because Get checks whatever you add, right? So if you didn't add your test cases, it only checks the one that we already gave you. So make
Okay.
sure you test your but even you don't need the check mark to make sure whether you're correct or not. You can really run the test cases in Eclipse and also see if they give you like this okay mark or they tell you what is the failure, right?
Right. So then, how would we do like so the expected will be like, let's say for withdraw, the expected will be that the array now holds the 4 of them, right? Not
Yeah,
the.
simply, okay. So for example, how I would do it, right? So you withdraw and then you can check whether this student is no longer part of the list or not by doing one of two things. Either um, like find, because you already like call the function find where you find a student, right? And then this student will return to you. I guess you were instructed to return -1 if it's not there, if I remember correctly, right? So basically, if you try find and it gives you that the student is not there, then withdraw has occurred correctly. Otherwise, if you find it with the find function, then that means you didn't really withdraw. This is one way of testing it, right? Another way is to really, because we after you have the list and you withdraw the student and you can calculate the average and then print the total grade file, and then this file shouldn't contain the student, right? So you go all the way to like recalculating like the average grades and dump it in a file and then compare this with the file you might expect, right? So
Okay.
you can see that this can involve multiple functions, right? And this is the nature. I believe this might be the first question we encounter something like this, which is, it's somehow a mini project. Like it's not really a project because it's a very, very minor like thing, but simply it involves multiple functions connected together. So to be able to test them in a meaningful way, you might need to call two of them, not just one, right? Yeah.
Okay, and one last, so then in that case, if I do destroy list, right? So in that case, if I'm using your output file method, that output file should contain no students, right?
Exactly. Yeah.
Okay. Okay. Thank you. That's all.
Yeah. Welcome. AK, for people who couldn't get their midterm, remarked, what will they do? Okay, so this is a general question. What I said yesterday in the office hours is, please send me an email with Combench to SH4 and then midterm and then your Mac ID, and then I will check this offline and then come back to you, right? Katie send me, okay. Vito, for lab 2, do we need to add this case for each function in question 2? I guess you are referring to lab 3 because we are currently in lab 3, Vito. You are required to add a test case. Simply what I said last time is you are required to test every single function you write, whether you add this as a separate test case, which when possible is preferred, or combining multiple functions in one test case, as I was just explaining right now, both are fine, right? Anthony, I don't have office hours today, but TAs have office hours every day, 10:30 to 2:30. Yesterday lecture is not posted yet. Katie, make the subject. Okay, was, does the size of student give the amount of memory needed for a student type variable? Correct. Katie, my test cases are working in Eclipse, but it's failing in Get, and it's just the same issue last time. I believe we didn't reach the limit yet, Katie, so it should be fine. But if you are passing locally, I shouldn't worry. Maybe something you can do is check the retail message that you get when you had this X red mark, like click it and look into what is the message, and this might give you a hint on what is going on. Salah, if you make a clock, can you free one part of it alone? Yes, you can free one location, given that the pointer you are sending is not the pointer at the beginning of the list, like it's one of like the end locations. Karina, how do you test destroy function using an output file? I guess I already answered this to Ishmam question. Expected in actual files should be 0 first line at dash. I keep getting a message that the structure student cannot be resolved. This is a common issue. I'm not sure about this Adarsh. It's more of a specific question that it's better discussed during office hours. Arjun, where do we free memory in lab 3? And this is something we have to do. Yes, Arjun, you have to make sure you deallocate the memory you allocate to where to do this. You have to think, should you do this inside the function? Should you do this inside the test case? So like make your own judgment in this regard. Okay, good. So today's lecture, I have already, I'm not sure why I feel the camera is a bit shifted, but okay. So today's lecture is already posted. So what we are going to do today is we are starting, I would say maybe this is the first real lecture in Java object-oriented programming. The past two lectures were more of discussing the syntax, what is different from C. We have seen some classes, but just in a very high level. So let's start this together. I guess we already mentioned this, but simply the mentality here is programs in Java use classes and objects. Everything is simply a class or an object of that class, including even arrays, as we said last time. There are two types of classes, the predefined ones, the ones that this is somehow similar to the header files in C. You can use already existing classes, and we have seen this in the scanner class, for example, to read input from the screen using the next end function in the first and second lecture. While you can also implement your own class and then define objects of these. Implementing a class is the extension of structures in C, right? So it's like in a structure. I told you, you define your own type. The same thing when you declare a class in Java, it's just the more general case. I'm not sure if you covered classes in Python in the first year, but I'm going to assume nothing about this. If you have the knowledge, that's great. But if not, then you will get to know it. Okay, so here is a very simple class. What I do is I declare my own class as public class. I call it interval, where interval is really the, why this thing doesn't write. Yes. That's interesting. Let me see. Okay, I guess I need to open the PDF then. That's interesting. Okay, reshare. Here's the PDF. Okay, we lose some of the animation in PowerPoint, but I guess it's better to use the pen for such a thing. Okay, so what I was saying is, here is we declare the class name. Come on. That's very interesting. For some reason, the pen is no longer working. Okay, check something here. Okay, anyway, so I guess I'm not able to use my pen this time, but simply maybe I can just try to use the keyboard, which is going to be terrible, in fact. Okay, so this is the class name. Sorry for this interruption. So I can call the class name anything. This is a normal variable. It just happens to be, I'm declaring a type right now, right? Similar to the structure name, right? And these are the members of the class, right? Like, I don't feel comfortable not using the pen. Okay, so here, just for simplicity, we are defining only two members, and both of them are double. As you might imagine, the class name from the class name is called the interval because it holds two things, like the left bound of the interval and the right bound of the interval. Good. And then later we will see how to declare different types, different objects of this class and how to use these members. We call these member variables or instant variables of the class. In Eclipse, I guess, as you will see in the lab, you can really declare a class by just creating a new file or a new class in your project, and it gets created by default in the project. If you are using the terminal, you have then to write it in a file called the class name.java, and then once you compile it, a class object, and now it's not an object, like, let's use a different terminology, a class file is going to be created in your machine. I guess most of you are not using the terminal, then simply you'll just be creating a new class in your project, as we will see in the lab. The rule here is, in one file, you can have as many classes as you wish, similar to, again, structures, but if you have only one of them can be public, and the class name, the file name has to match the class name, like the public class name. Here, for example, I define my interval as a public one, and we will discuss what we mean by public right now, but I define my my class name as interval, and it's the public one. That means I have to save this in a file called interval, exactly the same name. I start by a capital I and then the same name, such that I can operate in this class. Good. Then looking into the class members, I have, as I said, a left bound and right bound. Both of them are doubles, and we call these instant fields, right, or instance fields. These are the variables of the class. Here they are public because, as we see right now, you can use them from outside the class, but they can be of like private or any other specifier, as we will discuss later. The main point that we want to make here is by doing this, as you are currently seeing in the lab for the structures in C, by defining members in a class, you can define as many objects of this class as you wish, and every object will have two separate members, left bound and right bound. For example, in the memory, oh, I still cannot use this. That's really bad. This is completely not my style. Okay, so assume this is my memory, and I declare two objects or two variables of the class interval here. That means I reserve two places in the memory for this interval objects or classes. Every one of them has two member variables, which is left bound and right bound, right? So the same thing here. So these left bound and right bound get propagated for any object or get recreated. Instances of them get recreated for every object you declare of that class, right? And then how to create an instance of a class. Really, we have done this before for the scanner class. What you can do is, again, we differentiate between the declaration and the memory allocation. Declaration is just giving the name of the object. Here I say interval int1 or any other name. That's the variable that is going to be the object from that class. But nothing, as we said yesterday, nothing is getting allocated yet in the memory until you use the new reserved word. So the general rule here, for those who didn't get it yesterday, nothing gets defined or declared in the memory, I would say created in the memory or instantiated in the memory without the new reserved word. Here I'm only defining the reference, but it's pointing to nothing, right? Until you say int1 equal new interval, and now you create these memory places that we were discussing, right? Can you do this in one line? Yes, as we have seen yesterday, you can do this in one line. So picture, okay, forget about this. Here, you can do this in one line by saying interval int1 equal new interval. Good. And now you declare it and create the object in the memory in the same in the same line. Good. By doing this, you can refer to the members of the interval class by saying int1 dot left bound, which is this one here, or int1 dot right bound, right? This dot we have used in structures, the same thing, the member of operator, which means the right bound of the int1 object. What is the value? Good. So I guess, given we cannot use the pen, I might switch screens and share with you a piece of code to try it together. I hope you are able to see the screen. Okay, can I make it a bit bigger? Let's see. Okay, I guess that's good. Okay, so what do we do here? So I have my main.java class. This is the just normal one. I'm using also the online compiler that we have been using for C. And inside this one, I'm declaring, similar to the example we have seen in the slide, I'm declaring a variable int1 of the class interval. As you can see, I didn't need to include anything with the class interval here, as far as it's in the same project. Here I have the interval.java. This is what I was telling you. You have to have the file name exactly as the class name, and the class name has to be public to be able to use it in the main. These are the two members of the class. And then going here in the main to test this class, after declaring a certain object of this one, now I can access the member using the dot operator, saying, for example, int1 left bound equals something, or trying to print it. For example, if like using the print line, int1 dot left bound, if I run this one, I'm going to get 4.5 because I have already updated the left bound. I can also try to print the right bound, and this should give me 0 because I didn't update it at all, right? Right, you see here it's 0. Good. So this is how you would be using a class and define members of a class and access certain elements of that class. Let me see if there are questions, and then I will continue the discussion. Okay, question, Karina. Do we have to test the destroy function using the output file, or can you use the find? You can use the find, Karina. Do you need both of those statements to define a variable? Yes, both of them. This is not defining a variable. This is defining an object of a class. So it's a special variable, or as we called it yesterday, it's a reference variable. So yes, you need both, because you declare, the first one is declaring them, the second one is creating the memory space for it. On the other hand, they don't have to be two statements. You can have them on the same line as we have here in the slide, right? And in the code. We don't have to import that file. Yes, Ishmam, if the class is part of the project, you don't have to. Jack, I don't really understand the difference between a function and an object. Both just define and store things to be called on later on code, or am I misunderstood something? Let me know. That's a perfect question, Jack. So Jack's question here is, what is the difference between a class and a function? In a function, I can pass input parameters, I can set values, and I can return stuff, right? So a function can be used as the first level of modularity in a code, right? So you can structure your code in a modular way by using functions. But functions have very limited capability. For example, a function is only used to execute code. So it doesn't have a physical nature of its own. It only executes stuff, right? So it takes input parameters, calculates something, and then returns something. But as we will see later, classes and objects in Java is a more of a general concept, which is the concept of object-oriented programming, where it's better to represent things as objects, and those objects can include computation, and also can include definitions. So for example, here in this class, I really didn't use any, so let me go to the class. So I didn't really do any calculations, right? I just said I have a class called the interval. It has two members, right? So these two members, I didn't do any calculations on them, but by having them as one entity, I can refer to the interval as single object right now, right? So think of what you do in the lab for structures. You have everything within a student. Can you define a student function? And now this is really defining a student with his first name, last name. You can refer to this student, delete it, delete the student, or delete his record or her record, add a student, create a list of students using functions? No way, right? So objects are more of real representation of the real world, right? And we have a detailed discussion about this later, but it was a question to the point, so I wanted to elaborate a little bit more. Muaz, do these variables get initialized to 0 by default? We will discuss this right now. So the class must be defined outside the main file. If it's public agent, that's correct, because if you go here, that's also a good question. If we go to the main.java, you find that the file name is main.java, right? While here there is a class called main. You can call this class anything, and then it has to be public, and it's public by default, but it has to be the same as the class name, which means I cannot define my interval class here, because you would have two public classes, and that's not allowed. One file is allowed only to have one public class. And then one of them only would include the public static function main, as we said in the first lecture. We would need to import some stuff, but if not, if the class is in your own file, you don't have to import it. But if you are using some classes from the Java library itself, you would have to import something. So it's not really that smart if you think this is a smart thing. Okay, good. So let me go back to the slides. I just hope we'll be able to use the pen, but let's see. What about now? No. Okay. So good. So we have already discussed this slide by the example. Here, what we are doing is so this test interval class is the one that has the main, which is in our code. It's the main.java class. What we do is we are trying to print the left bound, the right bound, assigning their value, and then printing them back. So elaborating a little bit more in the code we have, what I can do inside this main, I can say before before really calculating or assigning any values, and this is going to answer Muaz's question, I guess, for initializations, I can say I want to print, say, right bound is, and then plus, and then maybe I have a space here. And then I would do the same thing for the left bound. And plus, oh, I'm going to do left bound is, this would be left bound. So what I'm doing in these two lines, let me see, smaller, smaller, smaller. Okay, it doesn't go to the same. Okay, here. So in these two lines, what I'm doing is before assigning any values, I'm just printing whatever int1 right and left bound are, and then later I'm going to assign them some value. And then let's say 4.5 and 5.5, and then print them back, right? Just do the same copy thing. What you'd expect to get is, let me see here. So at the beginning, they are 0. Oh, why? I guess I forgot to date something. Right bound. Yeah. Okay, so left and right. So at the beginning, both are 0, which means if you don't initialize or set the values of members of a class, we will see now what we mean by constructor. But basically, once you define it, it gets initialized to 0 by default, right? Once you instantiate the object. And then after setting them, printing them back, it gives you really the values that you needed, right? So hopefully this explains the slide in a practical way. So going back here, I've already done that. Test interval, we have already had this discussion. Now, I guess we go back to the interesting stuff. So far, we have seen all these things and structures in C. What is interesting in Java and what is interesting about classes, right? For object-oriented programming. So two main important concepts or like I would say paradigms or mindsets behind object-oriented programming. The first one is data encapsulation, and the second one is information hiding. What we mean by this? Simply assume the following scenario. A client, for example, wanted you to implement him a certain project, right? Like a certain program that achieves a certain task, and you're going to use Java or any other language, right? And then you are doing only part of the project. Someone else is doing another part. The point is, you don't need to expose your full implementation of the class such that others can use it, right? Until now, we had access to all the members of the class, right? Or the same thing, all the members of the structure in C, which means outside your implementation of the structure or your implementation of the interval class in this lecture, anyone can modify the values and implement them in just a straightforward way, right? So you are completely exposed to the outside world, right? Or to the user behavior. That's not a good thing to be done, right? Both from the security point of view, from the copyright point of view, and also really from the encapsulation point of view. The only thing you want to do as a professional programmer is you want to provide a modular interface for the user to tell him how to use your program and what output to expect. Now your code will be a black box. No one has actual access to the real implementation while they still can use it, right? So this is, I would say, in a very high level, the concept of encapsulation and the information hiding. And this is the whole mindset behind having classes, objects, and we'll see right now something that's called setters and getters in OOP, right? So the problem that arises, so let's say I take this mentality, right? Assume, okay, I kind of convinced you need to make yourself a little bit secure. You don't give full access to your members and the implementations, members of the class and the implementation. Then you say, you know what? I'm convinced I'm going to transform all of them to be private members, right? Instead of being public members. So in that case, if you are a private member of a class, really no one can access it from the outside world, right? So let me show you this practically. If I go back here and I modify my implementation such that one of these is really private, and then I go back and try to run my program, I should get a compiler error, right? And this error is saying left bound has a private access, which means you cannot really access it outside of the interval class, right? So no one can access this private member left bound. Well, but now I have done what you told me, and really my class became unusable, right? No one can use this left bound, right bound anymore. So what should I do, right? So for that sense, you need this balance between giving access to be able to use your class and secure your implementation, right? And the way to do this in object-oriented programming is really make all your, and this is a general rule, right? Take this as like a lesson you have to apply almost in any program you write. You make most of your implementation private, including all the instance variables or the member variables of your class. All of them are private, but then to give users access to them, you define public functions, and these functions are your interface, and we call this set function and get function. Simply from the name, a get will allow external wallet to get a certain value of a member, and a set means you are able to set it, right? So going back to the practical, I see many things on the chat, but let's go back to the example we have. One way to access these two while having them as private, I'm going to add another public function that I call, let's say, set. And then I'm going to set both, so set bounds, for example. And then this takes two inputs from the user, double L bound and double R bound, any name, doesn't really matter. And what this function is going to do is simply to say this, forget about the word this for now, you don't need, I will come into it now, but simply you need to say, I want to set my left bound, which is originally private, to the value that the user provided, and I want to set the right bound to the value that the user provided, right? And then now this is to be able to change the value. What about getting the value? Then we'd have another function called get, let's call it get L bound, for example. And then simply this is going to take no input and then just return, this should be returning a double. And it's going to return this dot left bound, and I would have a similar one for my right bound, but I guess you get the idea. So let's see here in the main. So let's just, I guess, does it make a different double? Let's now see how different I can use now my code. So instead of having a direct access to this, I no longer have a direct access. So if I want to read them, I cannot just say int1.write bound. As you might imagine, what I can say is int1 dot get r bound, and in this case is going to return to me the value of the r bound, right? And the same thing for here should be get L bound. So what I have done in these two lines is to say I have a way to access the left bound and the R bound, but indirectly. And now we will discuss why this is something that is meaningful and different than accessing them directly. And it remains to set them indirectly. And then this is to set bounds, I guess, if I remember the name correctly that I wrote. And then I would be providing, I don't know, the values that I want to set, 4.5 and 5.5. And now I have already set these. And again, if I want to repeat these to see if my set has happened correctly, I'm going to do that, right? So what I'm doing here, just let's take it step by step. The first one is in the class itself, I made these private, which means I no longer can access them, and we have seen the error that I guess it's still out there in the output console. By having them private, you want to also provide the interface for users to be able to read and write into them. For writing into them or setting their value, I defined a public function that I call setBound. It's a void function, so let me say void because it returns nothing. It just takes two inputs from the user and sets the values internally. And then I also define, I didn't define my write bound return, so it's going to give me an error. Let me do this, get rbound. In this case, it should be return write bound. And then to be able to read the values, I define my get functions for each variable. And this is a very simple function that just returning the value of the left bound and the right bound. Questions? Let me see if there are questions in the code. Question, Yan, how? So if all those two Java files are stored in the folder, we don't have to, yeah. Ishmael, initial values are 0 due to the constructor because of the garbage collector, because of the constructor, as we will discuss right now. When you create a left bound variable, it is set to 0, okay? You're gonna get extra bracket, okay. Oh, I guess maybe I'm missing something here now, but let's see. Question, is this same self in Python? Yes, how? Yeah, that's correct. Static, no. Static is a different thing, Sagnan. Static, and we discussed this in C. Static specifier is saying what is the duration of a variable in the memory, as we discussed in C. Private or public, on the other hand, is about the scope, right? Who has access to this variable, right? So, and we will come into static in Java, I guess, later in the course. We can omit the return type in method. Yes, if return is void, you can. If return is void, then you can do this. So public objects in a class can access private object in the same class. Public objects in a class can access private objects in the same class. I'm not sure if I get this vector, but you have two wallets right now. And I guess I'm going to try to draw this to you somehow. You have the black box of your implementation, and inside this one, am I disconnected? Yes, I'm still here. So, and inside this one, you have access to everything because you are inside your own code. You are the developer now, inside the box. Outside the box, you have no access except for the public members, whether functions or variables, right? Now, this is I'm going to, how I'm going to discuss this in details in a later slide. So don't worry about it for now, right? Okay, the main thing I want you to understand is this, the mentality of getters and setters, right? Why do we do this, right? And how it provides you access to the members while the members are still private. Good. So this is what we have discussed. One additional thing in this piece of code, before I elaborate more on the set and the get, is here we define a constructor as well. What is a constructor? If I go back to where I created an instance of my class here, in this line, what I'm saying is, please create for me an object called int1 from the class type interval. And by default, this is creating in the memory the object of that class. But there are members of this class you need to initialize. And many of you asked about these things. So what happens is when the compiler executes this statement and creates the object in the memory, it also runs a constructor by default. What is a constructor? It's just a normal method in Java, similar to any method, but it has the same name as the class name, and it gets called by default. You don't call a constructor, it gets called by default when you create an object, right? Good. So if you don't have a constructor in your implementation, similar to what we have before here, there is a default constructor which takes no inputs at all. And this is the one that gets called in this line because you pass no input parameters. And it initializes everything to 0. While if you implement a constructor, as we have in these lines, you really set the values of the L bound and R bound inside the constructor, right? So this is simply what you do. So I guess to show you the constructor, I need to jump back to the implementation and show you how to do this. So inside this class, what can I do? I say I want to have the same class name. Just take the exact implementation to match the slides. Okay, but that's too much to use the condition operator. We don't need the condition operator for this, but simply the constructor has to be public because it's called by default outside of the class, and it has to be the same class name interval. Now I have the ability to pass inputs while creating the object. In this case, maybe I want to set the bounds, right? So maybe I pass L bound, and also I pass the R bound, any two variables, right? And simply this constructor is going to say the same thing for the setting. And then is going to read LB and RB because these are our input parameters. Now, by having this constructor, if I go back to the main, I'm going to define two objects right now. One of them is calling the default constructor, which is this one. Oh, you guys are able to see my code, correct? Okay, so so this one is calling the default constructor, which is the one that is initializing everything to 0 or false, like similar to what we discussed in the first lecture. While in the second one, I'm going to call my own defined constructor, let's say interval, and then pass, I don't know, 2.54. Good. So if I try to print the int1 things, I will get 0. If I try to print, let me remove these things. I don't need the set for now. If I try to print the int2 ones, I should get the ones that I have already set, right? So let me run and see. I hope I don't have any typos or syntax stuff. I do have. Let me see, what do I have here? I guess Yanha was saying I'm missing a bracket or something. Arrow left now has a private access in interval. Oh, but do I still access?
Your print line calls it directly instead of indirectly.
Which one? This one? Oh, I don't see anyone that is calling it directly. That's interesting. Let me read it again. Main Java 7 left bound has private access. I get that's the old one. Okay. So interval int1 new interval default constructor. What's the problem with this? Required double. No arguments found. Action from unless differ in length. That's interesting because I should be able to run the default constructor even if I provide nothing. But let me see if I try this now. I can do this, and I take nothing here, and then I just say, I can either do nothing or just set it to 0 by myself. Right?
I think if you create a constructor, it calls that, and I don't think you can use the default one anymore if you create your own.
Yeah, so correct. So, but now what I have done, okay, that's a good point. Yeah, so what I have done is in fact, in C++ you can, and this may be what confused me. So you can even call the default constructor even if you have your own constructor. But anyway, so what I have done instead is I define two constructors now, right? The one that is resembling the default one, which is just setting everything to 0, it takes no input parameters. The second one takes two input parameters and set it to the values that the user entered. Good. So this might be confusing that you have two functions or two methods with the same name, different input parameters. This is called overloading, and we have one lecture for that. Good. But simply you can do this in object-oriented programming. And here, what happens is that the compiler is smart enough such that if you define an object using no input parameters, then it calls the constructor that takes no input parameters, and it initializes them to 0, 0. On the other hand, if you define another object, declare it, and then pass inputs, then it's going to call the one that passes the inputs, right? And by printing the first one, we know it has to be 0, 0. The second one is for 2.5, right? Any question with regard to this? So now we know what are constructors. These are methods, special methods that are called when you create an object. You can really depend on the default one which has no input parameters and just 0, 0, or you can implement it yourself. And the last thing we have done is you can have multiple constructors of the same class, right? Okay, any question? Now it remains to discuss, maybe the last thing in this lecture, what is the benefit of having setters and getters, right? So if I'm still able to, through this set and get thing in the main, I'm still having access to the variables, I'm able to read them and write into them. Why this is something that is beneficial then? I mean, what did I gain? Did I really do encapsulation? And is it any difference from just having the variables as public? What do you think? Is there any idea why using setters and getters is maybe the right way? It's the correct interface? Don't have to worry about accidentally modifying things. That's one reason, Arjun, that's correct. Then you cannot modify outside, but if I have a set, I can modify Abdelmonem, right? Read only, write only control. That's also another benefit. No, that's correct. So what is the point here, right? I wish I was able to use my pen, but maybe next time I can see what is the problem and try to visualize it for you. But the point is the following. I guess I had an empty slide for this here. This is all about constructors. We already discussed all of this. And this is discussing the constructor back again. We have done the example already. Setters, getters. Yeah, why set and gets? Okay, so let me try to draw. So this is, hopefully that's a very bad drawing, but anyway, this is our class interval, okay? I will try to write interval here, but okay. This is our class interval. If I had everything as public, like my two variables L bound and R bound, that means there is a direct access to these, right? Correct? So if these are my boundaries of the implementation of the class, any other class in the project or the user itself can really access them directly and modify them, right? If these are bank accounts, for example, it's not safe to do so, right? Then what to do? I'm going to say, instead of providing this direct access, instead of providing this direct access, yeah, eraser is here. What I can do instead is I say, I'm going to give you an interface. And this interface really defines the contract between me and you of what you can read and what you can write. And I have the full control of this interface. What I mean by full control is inside the get or the set, I really, for example, can add an additional code to say, if the user is trying to set the L bound, for example, to be a negative value, and I don't want this to be a negative value, then I'm not going to override the value, right? This is just one way to let you know you really add an additional mechanism to control what are the values that the user can input. So by providing the get and the set, which is your interface here, these are called getters and setters. So maybe I should just say this is the get. And this is the set. I'm not sure if I'm doing well in trying to write things, but so, okay. So by having this set and get, you really have the control, which I have here as this arrow, to define what are the values that are not allowed or prohibited, when a user can modify something, when he cannot modify something, and then internally how you modify these. Assume, for example, you defined your L bound and R bound, and you use them inside your class. This was a very simple class that doesn't do many like calculations inside the class itself, right? But assume, we will see this later in lab as well, you use these variables inside certain functions, like read them, do some calculations on them, and then use them in other things. Then you might have access to say, I implement them in this way because I want it to be done in this way inside my function, but the user can only set them in under a certain condition. That's one thing. The second thing is, what about next year, after you finish this project, you give it to customers, you decided to improve it. So you have version like 2.0. And in this version 2.0, you decided to change the inside implementation. In the previous version, where users had direct access to your code, wow. User had direct access to your code. If you change anything here, every code that is building on top of your code has to change, right? Because I might have built like thousands of lines, classes and projects that are dependent on reading L-bound and R-bound, right? Or generally your member variables. Now, if you change the way you implement them, I have to change all of this. So there is no modularity here. On the other hand, as far as I maintain the contract that I give you through the set and get, I can really change everything here in the implementation. And this is another benefit of encapsulation, which is modularity and extensibility, which means you are able to extend your code, modify it, improve it, while everything is just hidden from the actual user, right? And this is one main concept that is driving code versioning, for example. Like I can have one version of the code, give it to customers. Next year, I have much better version, while I can still maintain compatibility with the old version. Do you now see the difference between why maintaining the contract of the interface through set and get is really completely different than having member variables as public, even if it might, in our simple example, do the exact same functionality? Any question? This might seem like theory, but really understanding this is key in object-oriented programming. You might be writing code, looking into functions. Again, I'm not looking into coding here. You shouldn't be a programmer. You should be like a software engineer, if you say, right? That means you understand the mentality behind the way people are writing professional code, right? And this is one like important aspect of this mentality. Any question? I don't get how it's increased modularity. So, okay, yeah, now again, so let's look into these two versions. In the first one, you expose all the implementation through public definitions to the outside world. I take your code, I write my whole code based on the fact that I can access these variables directly in a certain way, right? So now this code, which is my code, is completely dependent on the internal access to your code. So if you modify anything here, and this modification is not compatible with the way I used your code, I have to change my code, right? If that's clear, let's look into the other way. If I achieve modularity by this set and get interface, the only thing I'm telling you, I'm only giving you the information that you can read this variable. How did I implement this variable? How do I use it internally? You really don't care and you don't have access to. So if I fully change the implementation here, it really doesn't matter as far as I maintain the interface through the set and the get, right? So you maintain a contract, and this abstraction is a very important concept in engineering in general. This is also the concept, if you remember our first lecture when we said the instruction set is the contract between the software and the hardware. How people are able to operate in software independently, completely independent to some extent, independent of the underlying hardware by maintaining a contract, which is the instruction set, the ISA contract in our first lecture. And as far as I maintain this contract, for example, the ARM instruction set or the Intel instruction set, Intel can provide every 2 years its own new architecture, completely different implementation, while you can still run your exact same code. Why that's possible? Because Intel maintains in the new architecture the contract of the ISA, right? This is exactly the same concept here, abstraction as well, where I only provide the contract through the interface. We have seen this through the symbol set get. The inside details of the implementation, you don't care and you don't have access to. So I can modify them, and really this doesn't affect your operation. I hope this answers your question. If you change any, I mean that's then not modularity. What we usually mean by modularity is you're able to change your code in the least effort way, right? So yeah, if you maintain your code exactly the same way, then yeah, I can still use it. That's correct. but now you suffer from the problem of security, right? You give me access to everything. Okay, good. So I guess we already passed time, so we are done with the lecture. I will also stay for a couple of minutes to take questions, and then you guys are free to leave. Okay, no more questions? Good. So thanks everyone then, and then I will see you on Friday. Have a great day. Bye-bye.
Hello.
Yeah.
Can I ask a question on previous slide?
Sure, go ahead.
The slide title, creating instantiating an object. Like, I wonder, have you go over that slide?
Yeah, most of these slides I have done through the example, right? But let's see what is your exact question here. Do you know which slide is that?
There's maybe slide 6.
Constructor, not a constructor. Private fields, not that one. Member access private, not this one. Class test interval. So yeah, create this one, instantiating an object.
I guess one previous.
Okay. Yeah.
Sorry, one more.
Okay.
Yeah, this one.
Yeah, this one is really not. It just shows the different way of defining classes, but forget about this one, right? This one we have already. So what you want to know here is, first of all, there are two ways of declaring and initializing, declaring and creating an object in the memory, which is you can do this in two separate sentences by first declaring it and then using the newly served word, or you can do it in the same line. The second thing is through the constructor, you can provide inputs by calling different constructors, right? This is all what you want to do. The third thing, which is used here, and we have done in the previous lecture, and we are going to do in next lecture, is if you define an object, you can really assign an object to another one. And by this, both are referring to the same thing, right? Here I'm declaring interval 3, and interval 3 equal interval 1, which means both interval 3 and interval 1 are pointing to the same object in memory. Yeah.
But what's the difference between the second line and the fourth line? Is there any difference?
No, there is no.
Yeah,
okay. So what is the point, right?
Yeah.
The point is if this is even allowed, because you really, if that is going to be multiple definitions, so this shouldn't be allowed, right? So don't worry about this one.
Oh, okay. I saw there is some point over there.
Yeah, so I guess the point here, if you don't have this definition, if you just set the object to a new object, then it's going to override the old one. What does it mean is you can make the reference really points to another object. What about the old object you created? Then it's going to be destroyed from the memory, right? Do you see my point? You can make a reference is pointing to a new object, and hence the old one is going to be destroyed in the memory, right? And I guess we also mentioned this last time. If you set the array name to null, then you are not using its memory, or if you set the array name to another array using the newly served word, the old one is going to be deleted, right? But you cannot just use this thing here. This is going to give you a syntax error by multiple definitions of the same same variable. Yeah.
I see. Thank you.
Yeah, welcome now. Let's say questions. Sure, Jack, go ahead. I will look into these. Yeah, go ahead. Ask your question.
Okay, thanks. Can you go to the code you had on the compiler online?
Sure. Let me see. Where did the sharing button? Yep.
So I was a little confused as to why, like at the top of the code, you named.
Like the interval class?
Yeah, where do you define interval class?
Yeah,
it's right there, right?
Yeah, in another file called interval.java. Yeah.
But then how come you have like the line right under public interval, when you have no like input parameters, it defines it as 0, right?
No input, you mean for this one?
Yeah, for that line right there.
Yeah, that's a constructor. You mean line 5, right? The
Line
constructor.
5, yes.
Yeah, so that's a constructor which is resembling the default one, which takes no input parameters. And there I say maybe if you have no input parameters, I'm going to initialize them to 0 by default, right?
But why
You
do
can
you
really, yeah, sorry, guys. Let me add one thing and then
Yeah.
You can really add anything here. I can really make them 10 if I want, or 20 or anything. It's up to you, right?
Right, I understand that, but why is it named interval?
Yeah, why it's named the same as the class name, correct?
Yeah.
Yeah, because that's a constructor of a class. What is a constructor? Inside a class, I can have functions like set bounds, get, and these things. These are normal methods. I mean, in Java, they are methods, but simply they are like functions in C. While there is one special type of method, it's called class constructor. And this class constructor has to have the same name as the class, and it has to be public as well. And what is special about this method? This method gets called by default when you create an object of the class. So if you go back to the main, in this line, you can really think I never called the class like the method called interval, right? And just created a new object, right?
Right.
But once you write this, the constructor is going to be initialized by default. And I have shown you this by line 6, which is giving some values. Then when trying to read these values, we found really the L bound and R bound are set to these values. How they are set? Because this method is being called, right? And set the values. Why it's called? Because it's, sorry, not this one, it's the constructor one, yeah, this one. Why it's called? Because here, when I created the object, by giving 2 inputs, I instructed the compiler to say, I want to call the constructor that takes 2 inputs. So the rule is when creating an object, there is a constructor that has to be called. Even if you didn't call anything, the default one is being called, right?
But then how come back, like at the beginning of this example, you named it set bounds?
Yeah, that's it. Sure.
Like what would be the difference? Why would you need a constructor when you can just make kind of a function that would do the same thing?
Good point. Why do we need a constructor if it's just a method that I can really implement it in another function? This function that you're going to implement, which is the set bound, you have, as a user, you have to call after you define your object to be able to set the values. While for the constructor, I'm enforcing you, once you create the object, to have certain initial values. Usually constructors are used in the practical use case for that purpose. As a programmer, when I write an application, I know my program is going to work correctly under certain initial conditions, correct?
Yeah.
Then I'm enforcing you to run these initial conditions by putting them in a constructor. So if a user creates an object, now I guarantee as a programmer that those, by creating the object, the constructor is being called and those initial conditions are being executed. While if I wrote this in a function or a method, the user might not call this method. So now you depend on the user behavior, right?
Right.
Yeah.
So like, I understand that now, but because right now you're defining it as 0, but it would automatically do that anyway.
Yeah, the 0 is automatically done by default. That's correct. Yeah.
Okay, so I guess if you wanted it to be like 10 or something,
similar to what we have done in the second one, right? This
okay,
one.
yes.
Yeah.
Okay, yeah. This makes a lot more sense. Thank you.
Yeah, welcome.
In the interval, sorry, I just have a quick question.
Go ahead, Arjun. Yeah.
Regarding this file. So in the interval.java file, do we write these constructors and everything as methods inside the method for the whole interval, or are these written separately? Do you know what I mean?
Yeah. So they are inside the class, right? So everything here has to be inside the class. As you can see here, we close the bracket of the class last, right? Otherwise, they are not members of that class, right?
Right. So when you define the class, it's 2 like data type variables first, and then you can define all the methods.
All the methods of the class, and these are called member methods. We'll elaborate more on this in later lectures, but you are correct. All the member methods and member variables have to be inside the class. Otherwise, they are not members of that class, right?
Right. Okay. And then in Java, I guess my other question is, we don't write like specifically functions. We write classes that do operations and don't hold values, right? And that's what a
You
function
can
is
write,
in Java.
yeah, you can write functions. For example, I guess in the last lecture we have wrote a function inside the main class, or here also we have few, or not functions, methods in the Java terminology. We have implemented them, but generally the correct way is to implement these inside a class, right? So
Right.
you want to encapsulate everything in classes, and then those classes would have member methods, right? And now you write your logic in this method, right? So people usually, I guess next lecture I'm also going to discuss this in detail, but the terminology here is the following. Every object in reality has two components, right? In physical world, has its own characteristics, which can be defined using member variables, like for example, your age, or a student. Let's take the student class, right? The student structure that we had in the lab 3. A student can be defined as like date of birth, ID, I don't know, your Mac ID courses, you take this thing, right? So you can,
Right.
I can define you as an object, as a student, using these characteristics. The other thing that any object would need is how he or she would react. Those are the actions of the object, and those actions are resembled using the methods, right? So member variables of an object resemble your characteristics, while the methods resemble your actions. Like if you take certain input, how this is going to stimulate what action you would take, right?
Right.
So
Okay.
think of any physical object in the world. Like, I don't know, people usually do this funny thing of saying dogs, for example, can be objects, because a dog would have, I don't know, a dog would have a name, I would say a type, a length, a weight, these things, an age, for example. But also dogs bark, for example, right? They run, they play, and these are actions, right? So there are actions, there are characteristics. Actions are methods, characteristics are data variables, right?
Right. Okay. And then why is it that sometimes you do public void and then other times you don't? Like specifically in the constructor, do we not do void type for constructors?
Really, if it's void, it doesn't matter, right? So it's because void, you return nothing, so you don't have to write it, right? I guess in one of the implementations, I didn't write it here, or did I? I guess you don't need to care for void, but simply for interval, we know that, sorry, for constructor, we know that a constructor is not allowed to return anything. And this is another special thing about constructors, because constructors get called by default when an object is created. So they must not return anything. Otherwise, I mean, where should I take this return from the constructor, right? In my main. So they return nothing at all.
So
right?
when stuff's not returning things, we don't, like, it's good practice to write void, but we don't have to write void.
Yes, I would say. Yeah.
Right. So like in public void set bounds, I could have just written public set bounds.
Let's try it together, because sometimes I get confused between C++ and Java. Let's try it together. I guess it complains.
Yeah, return type required. Okay.
Yeah, so I guess it might be only for constructor.
So
right?
only for constructor, you don't have to use void. Otherwise, if you're writing a method, you have to say void if the method isn't returning anything.
Is not returning anything. That's correct.
Okay. All right. Thank you.
Yeah. Thanks, Ajay.
Hi, excuse me.
Yeah.
Because of time limitation, yesterday I don't have a chance to show my midterm with you. So you mean I just need to email you and?
Correct. Please email me, and then I will look into it offline and get back to you.
Yeah, I already emailed you. Thank you.
Okay. Yeah, I didn't have a chance to look into them yet, but by tomorrow, hopefully, my plan is to get back to everyone. I guess Muaz also had a question about this. I'm sure if he's still around, but yeah, tomorrow, I guess Muaz, you should hear back from me.
Thank you.
Daniel, in Eclipse, if Java is not in our respective tab, well, we have to install a different version of Eclipse. I guess Java comes by default with Eclipse. You can create new project and then it tells you Java project. So I guess this specific thing I might better look into in the tutorial and also during office hours, but I believe in Java you don't need any additional thing to install. Yeah, so try this, Daniel. Try like file, new, and then project, and then it gives you certain options. Java should be one of them. If it's not one of them, then I guess we should investigate this. But this is how I would create a Java project. Salah, I have a question about the lab. Can I ask you right now to understand some concept? If it's a quick question, because I have another grad course soon, Salah. So are you still here, Salah? Okay, so I have another grad course. So I have to go in 3 minutes, but
it's pretty quick. Basically,
yeah.
in the first part where we're creating the class, we basically make a calloc that holds a double pointer class list, and then you make like a for loop, and you say inside this calloc, each one is a calloc that holds the value of one student.
Correct.
Right?
Exactly.
So,
yeah. Exactly similar to what we have done in the lecture.
So yeah,
right?
but
if you really copy the code in the lecture and paste it and then modify it for the student, it would work seamlessly.
Yeah, and that's what I did. But in the first part, you only say the student ID, first name and last name, because that's what the first part is. You don't put grades still, because grades come in later functions, right?
What I remember is also there are the project grade. There are 2 grades.
Yeah, the grades should be 0 by default at the start, basically.
Okay, if that's the case, then okay. I don't remember that was the case, to be honest, but I guess yeah. If that's the case, then
so yeah, basically in the first function I put the student ID, first name, last name, but I never defined the grades to be 0. So how will the calloc know that? Like basically, I make another calloc for each student. Okay. So how will the calloc know that the third part of the basically like calloc as if it's an array, right? So calloc is like an array.
Okay.
So the first one will hold the student ID, second one will hold the student first name, the third one, like the third part.
What is first? I'm not sure if I'm getting what is first one and second one.
Like the first,
when
like
you say
the
first
array,
one,
basically
which
calloc
one
is like an array. So the first element of the array, and then the second.
Oh, no. Okay. I see now what is your confusion. I guess you should look into our in the structure lecture. We had a 2D and then structure stuff. You should look into this because one student should be only one entity of a structure type, and everything is inside this structure type. You don't create multiple array entries in your terminology for a single student. And this is why we are using structures here, right? Every single entry in the array is one structure, and this structure has all the members, right? So I guess, Salah, what you need to do is first look into 2 things in the lectures before looking into this question, because I guess you are making your life much harder. The first one is the 2D array allocation through malloc or calloc. And the second one is structures. I guess in the structure lecture, even I had example with 2D for structures. If that's the case, then this is a straightforward one you can look at, right? Because simply what you want to do is for every student, you really only create a single entry in the calloc, and this entry is your structure, right? So you don't have one entry for the name, one entry for the grade, one entry for the ID. It doesn't work like that, right?
Okay, yeah.
So look into the structure lecture first, because I guess this concept needs some clarification in your mind.
Okay.
Yeah.
Thank you.
Does this clarify
does.
things? Okay, thanks. Then if you're confused to where to put the free for question 2, I try putting it in the test and it says the variable is undeclared. So Danny, the variable will be undeclared because you have to know what are you passing for the free. Like the pointer that you are passing for the free has to be a pointer that is has the scope of the one that you are calling it, right? So that's, I guess, the main thing. So you need to think about it. So what pointer are you passing to the free? You cannot use the pointer that you already defined in the question, not in the test case, because this pointer will not be defined and it will give you the error undeclared, right? Does this?
Yeah, I changed it to the same one that the test case used. I think it was called CList. I don't know if that was the correct way of doing it, but I did change it to that one, and it didn't work or something happened, so that's why I was confused.
Yeah, because it's a 2D one. Another thing I would say you should do is look into the lecture where we define the 2D array, because you cannot really deallocate the parent one, like the double pointer one, before you deallocate everything else in I guess we elaborated in the example in the lecture, and we highlighted this error specifically. Right? You have to deallocate all the elements one by one before you deallocate the C list, which is like the double point. Right?
Okay, so then like I guess you'd use a loop for that, I guess, and then go through all.
Yeah. You can, yeah. And in the lecture we have the example for the loop.
Okay, thank you.
Yeah, welcome. Okay, thanks everyone. Yeah, sorry.
Yeah, I just want to ask a quick question about the lab, really quick.
Yeah.
Do we always need to free those memory after we done the function or
yeah. Any memory you allocated, you have to free.
Remember
otherwise,
one time you say there is some memory we are supposed to not to free. I wonder, have you mentioned that before or not?
No, that's not the case. So what I mentioned, I guess if I remember correctly, is you have to know where to free, because if you free and and then later you want to use it, you will not be able to use it. Right?
That's what you mean. I see. And we always need to free after like.
Yeah. Any malloc or calloc, any dynamically allocated memory, you have to free. Otherwise, you are reserving places in memory that keeps even after your program finishes execution.
Okay.
Which is
just
bad.
Making sure. Thank you.
Okay. Thanks.
Wait, so
thanks everyone. Yeah, go ahead.
Sorry.
Go ahead.
I was just gonna say with that, like according to that question, so if I'm troubleshooting it and I don't have the free in it, that will just keep taking up memory in my computer, right?
Correct.
Okay, correct. So then I have to do that if because I did that before. So now is that memory just like gone?
Yeah, if you restart it, or you have something has to happen in your machine. The operating system, some operating systems are dealing with memory allocation in a smart way, knowing that, for example, if a memory gets allocated for a very long time without being used, they take ownership for that. But in most cases, it may be safe to restart your computer. Right?
Okay. Thanks.
Sorry, just a quick question.
Yeah.
So such as a question driven, you told us we're allowed to use the string copy, yes. So we copy all the word line, those string to a string what I created, but I don't know the size for my new created string. So is that okay? I just set a huge size for that string and make it for the copy one.
That's question 1, correct?
No, question 3.
Question 3, oh, for the word,
I
right?
mean, use a string copy. Yeah, for the word.
For the words. But question 3, you already have the number of words you want at the beginning of the file, right?
Oh, yeah.
Yeah, so you don't have, because otherwise, I mean, how long you can allocate stuff in memory, right? This, you have to be efficient as well. So you have to use this number to make sure you only allocate whatever you need, right? Does this make sense?
Yeah, and also for the free. So you mean, is that okay? I don't write a free in this lab, but because if I just write a free and I need to make it write it in the main function for the test cases.
Well, you don't have to make it in the main. You can make it inside the test case itself, right? Or you can, even if you don't use the function you don't use this memory outside the function, you can even do it inside the so 2 places you can do this free according to whatever function we're talking about. Inside the function itself that you did the malloc or calloc inside, and that's the straightforward way, or inside the test case that is using this function if you need the memory you allocated for the test case, but you don't need to go to the main and do it inside the main. To answer your question, you have to do a free, otherwise your program would cause a lot of issues, right? So it's not a correct programming practice to not free memory that you dynamically allocated, right? So you have to free it.
Okay. Thank you.
Okay, good. Yeah, welcome. Okay, thanks everyone. I hope this was the last one, and I guess I have to go. Have a great day.